Okay, the first things when you look at this problem, the first step is don't panic. Okay, it just break down the model into elements, nodes, then everything becomes more obvious. Okay. For a question like this, okay, every time I design a midterm or final exam, guess what? I am you. I try to work on this problem set at least once or twice, to shake down all the errors, okay, before I publish that and issue to you guys to work on. A problem like that, right, with a truck on it, it takes me about 45 minutes. So you will have 2 to 3 problems like that in your midterm or final exam. By the way, for midterm next week, you have 4 questions, okay? And I promise you, nothing strange. You've seen all this before. But of course, you've seen it, but not identical. If I give you the same thing that you've seen in the examples or in the quiz, it's not university 4th year anymore, okay? So I will give you like framework, how you work on it, but in the step-by-step process, you still have to work on it. So that's why it takes form. Okay, anyways, okay, first step, I see there's a bridge, okay, and on top of the bridge, there's some uniform load. I assume it's decking, asphalt, okay, whatever. And then on top of the bridge, there are some point loading, some lampposts, 2,000 pounds each. There's a truck, 10,000 pounds, okay, and in the middle of the bridge, there's a column, okay. And look at that, there's a little blue line right here at the middle of the model. What does it mean? Okay.
The
Participation.
center, the
Yeah.
center of gravity of the truck is over the center of the beam.
Over the center of the beam, and also what else? I love shortcuts. I love shortcuts. This is a
Yeah, the
symmetric
bridge is symmetric above that line.
symmetric boundary condition. Say, and another thing, usually I don't do that, but in this problem set, I provide a node number. Okay. Usually I don't, but somehow this one I was being nice, so I provide a node number to you already. Some of the node number, then what? Okay, I can find out we have 3 elements. This is a beam. It's also a beam. And also the whole model is a full column, right? But now because of the symmetric boundary condition, it is a half spring. And also the truck is loading right at the center of it, right? So it is a half truck. So which
So,
is
Professor,
negative, yeah, hold on. 5,000 pounds. Okay, what is it? One at a time.
So to assume the symmetric condition, we have to assume that the asphalt is on the other side of the bridge as well, weighing 1 pound per inch, or no?
The asphalt is everywhere, 1 pound per inch.
Oh, that's on the entire bridge. Okay.
Entire bridge, everywhere. Yeah. Okay, more questions?
Is it half beam or half spring? Like from 3 to 4. Like
Note
I
3
thought
to
it's
4. Why is it a beam? Why is it a beam? Okay, the thing that we distinguish between a beam and a spring is that, first of all, I don't see any uniform loading on the side of it. Okay.
okay.
Right, and then I have a uniform loading on the beam itself, and also from the problem set, I see there's only loading acting axially along the spring, along the column. Okay, I don't see any loading like this. Okay, it's all downwards, right? So this is I can, and then I take this, I can, you know what? If I want, I can use truss elements to do it. But why would I do that? Because I just use the most simplest tool to solve problem. Okay.
If we had a uniform loading, so would that be a beam as well?
Then it's really mess up, because if this is a beam, okay, I have uniform loading on the side, but somehow I'm not taking any load from the truck because the beam elements doesn't detect the loading along the beam, only on the side.
Vertical. Yeah. Okay. Okay.
Yeah.
Okay. Makes sense now.
Are
But,
we considering the uniform loading from S-flat?
say again, I'm sorry, I missed that question.
So the S-flat have uniform loading of 1 lb per inch, right? So obviously the beam that's supporting the right underneath the truck, it has some part of S-flat on top of it. So are we considering the uniform loading from that part?
Yes, of course. No, we let the matrix look after it. Okay, guys, don't think too complicated. Oh my goodness, this column right here is taking the truck, it's taking the lamppost, it's taking the uniform loading. No, don't worry. Let the matrix, let the finite elements help you. Okay, that's the beauty when you do the global matrix, global force vector. We put everything together instead of worry about each of them individually. Oh, 2,000 pounds, 5,000 pounds, I panic. No, we stick with the plan, pre-processing plan. Like those are answers tutorial that I show you. Oh, by the way, try to work on answers. It's all related to everything, you know, it's all related to it. Step number 1, plan it, okay? We have one beam element, we have another beam element, and we have one more element, just half the spring element. And each beam, each beam and each string element has its individual loading. Okay. And then we'll combine them together and we'll worry about them. We don't even worry about it. We put in the equations and boom, everything will be calculated for me.
Chris, can I ask a question?
What is it?
Yeah. Why do we say this half spring for the column?
Because it's symmetric. Symmetric. The whole thing is one spring, but now it's half of it.
Okay, thanks.
No worries. Okay.
What happens to the boundary conditions at the beam between nodes 2 and 3? Is there a moment at 2, and do we know if there's a moment at 3?
Oh my goodness! Again, you know, we don't worry about every single one. You know, we will let the force. Okay, I will come to it. We let all the force from each part put in the part, put in the global matrix, solve it. Then you don't, as long as you don't miss any boundary conditions or applied load. What is the individual moments, torque, whatever? Oh my God! Don't think too much, man. Let FEA look after it. Okay, let's move on. What's the total length of the bridge? Come on, this is so simple, man. What is it? The total length of the bridge is 250 feet times inch per feet. So what is it? The total length is 1,000.
3,000.
3,000. Sorry, man. I'm sorry. 3,000. The local stiffness matrix between nodes 1 and 2. Okay. I was so nice beforehand, you know, like between nodes 1 and 2 is what? It's a beam element. What is the force? What is the equation? EI over L cube, right? That's, and then times something very big. So EI over 3 to E 100. Okay, the total length is 3,000. Okay, it is evenly divided. So each section is 1,000 inch. This is also 1,000 inch, but we don't care. So the second beam is totally half of it. So it will be 500 inch. Okay, question so far? No? Okay, so it will be 1,000 to the cube. Okay, for the beam element matrix, it's 12. And then, oh, I lost my formula sheet. Okay, when you work on a midterm test, right, you must have your formula sheet side by side. You can refer to it. Sorry, give me a second. Okay, 6 times L is a 1,000. Negative 12. Okay, 1,000. Okay, I'm getting lazy here, so I just write E6 e to the 3, and then this steps are 4 times L square. L square is 1,000 square. Anyways, you know what I mean, okay? Just do this for all 12 terms, okay? 4 by 4 matrix. Then you get this. Yep, this is the stiffness matrix for beam. You know what? To make it clear, let's call the beam 1. Okay. Okay. Question C. Apply force contributed by the astro between nodes 1 and 2. So easy. And this will be a force on beam 1 will be okay. You know what? I'm not gonna rewrite the formula. Okay. The astro is a 1 pound per inch. However, it's acting down, right? Astro is working down, so it's -1. The length is 1,000 divided by 2, and then the next one will be -1 times 1,000 square divided by 12. Oh my goodness, why did I do that? It's -12. Okay. Okay, again, merge. I'm not going to show you step by step, but you know what I mean. You know, you get the formula sheet, plug in the number, you get a force factor of the beam 1.
Chris,
Yeah, what is it?
can I ask why in the force vector, why, so it goes WL is positive, WL squared is positive. Then your third term, how come that third WL over 2 isn't a negative term, whereas the fourth WL squared over 12 is a negative term?
is from the development of the integration.
Okay.
Okay, you know what? Let's to avoid any confusion, I'll finish it for you, just for you only. Okay. So in this case, -1, and then the third term is always the same as the first term. 1000 divided by 2, and then because it's a negative load, so now become plus 1. 1000 squared divided by 12.
Okay. So that's
Okay.
just the way it works out through the integration.
That's right. You know,
Okay.
stick with the plan. You know, you have this formula sheet. It's always same. It's not going to change, but depends on the W. Okay. In this case, W is -1 pound per inch. Okay. If I have a beam, I have crazy loading like this, and then let's call it what we cause that? Okay, how about wind blowing upwards? Wind blowing upwards, you know, is let's say 2 pound per inch. Then in these equations, you will be plus 2 times 1000 divided by 2, something like that. Yeah, but in this case, it is an astral going down, so it's -1. Anyways, we have A, B, C. Now let's work on D. D, what is it? Local matrix between nodes 2 and 3. Aha. We E, I, okay. I'm not gonna rewrite that. E is same thing. 3 exponent of 8. I, same thing. We're not changing that. But this time the L is different. It's a 500 to the cube. Remember, it's only half of the 1000. Okay, so it's a 500 times the ugly stiffness matrix is what? 12, right? 12, and then it's 6 times 500. -12 again. 6 times 500. 6 times 500. Okay, it takes a lot of patience. Okay, so you do the same thing for all 12 terms. Do not panic. Okay, step by step. Then we have E. What is it? E. Determine the applied force by astral between nodes 2 and 3. By the way, guys, this question has a lot of babysitting. You know, it just tell you step by step, you know, how you do it. You study it as a guideline. Eh? That's how you approach to FEA problem. Okay. Very often you don't have that. Okay. Force beam 2. Same thing. Negative -1. But the L is not 1000 anymore. It's 500. It's half the beam. And -1 times L squared, 500 squared divided by 12. Same thing. Okay, then we get force. Okay. The next things, F, the local matrix of the center support. A is 20, E is 3 times 3E5. Okay, center support is a EA over L. What is E? E is a 3 to the 5, 3E5. Area is 20 times 20. divided by L is what? How tall is the column?
Oh, question.
Yep, what is it?
Is 25?
Wouldn't the
25
area
feet.
be divided by 2 as well, if we're considering the symmetry?
Yep, it's coming up 25 times 12 because I want everything in inches, right? The column is 25 feet. 25 feet. So it's 25 times 12. Okay, this is the whole column, right? But I want the half column. So I 2 half column. Okay. So do I have all ingredients? Okay, then the next part is the global matrix. Do I have all ingredients for the global matrix? I guess so. We have it all. Okay, now that's a little trick I want to show you. Before we combine everything, right? We must know the address of it, right? We must know the location of every single entries has a new address. We must know where they are. Okay. So what I do usually is I write the displacement vector right beside it, just to help myself to visualize the new address. Right here will be V2 angle 2 and then V3 and angle 3, right? And then finally we have, okay, right here will be V3 and V4. Questions? I don't name it U3, U4, whatever, because first of all, the spring is going up and down, right? Okay, the spring is going up and down. Is there, okay, did I miss any question on chat? Is there any case the uniform loads acting upward? Nah, I just gone through that, yeah. Is the wind load or something? Formula. Okay, let's move on. When I assemble the global matrix, I like to start with the displacement vector. When I join everything together, V1, phi 1, V2, phi 2. This is being shared by 2 beam elements. Okay, V3, V, and then we have V4. And it's a 7 by 7 matrix, so I want it bigger. Voila. And then I have a right here, we have a force. Let's call it a okay. You know what? Let's write it down. No, so -5, oops, 500, and then what is it? -1e6/12, right? 1000 square over 1e to 6, and will be right here is also 500. This will be 1e over 6/12. Okay, and for force beam 2 will be 500 divided by 2 is 250. And then right here, oh my goodness, 500 square. 5 times 5, 25, 100 times 100, e to the 4. Okay, -25 e4 divided by 12. This is so bad. This is not 2, it's 12. And then third term is equal to the first term. And the fourth term is equal to the second term, but different sign. 25 e to the 4 divided by 12. Oh, what a mess. Okay, now we assemble together the first. Okay, by the way, do you have issues to assemble the global matrix? I'm not going to go through that because you have the new address, right here. And then we v2 phi 2 v3 phi 3, and right here we have v1 phi 1 v2 phi 2, and then v4. Okay, you just from the old address we move it to the new one, 7 by 7. Okay, just put them in the pot. Okay, it should be very simple. Okay, I want to go through how you assemble the force vector in this case. It's more complicated. So we will be the first set will be a negative 500. Oh, I should write it bigger. It's a big force vector.
Sorry, for assembling your global, before you assemble it, you have to make all your K values the same, correct?
Oh yes. Good point. Because right here, all the K values outside. Okay, if you have a different K values, it's like a scale factor outside the bracket. If they have different scale factor, you cannot just say, oh, right here is a 12 and 12, it becomes 24. Wrong, big problem. Okay, you times in the scale factor, then you assemble together. Good point. Good point. If you just add the 12 by 12, oh my goodness, you screw up everything. You have to make sure all. Okay, right here we have 3 terms, right? All scale factor times 2 it. Okay, then you can add them together. Okay, let's go back to the force factor, right? The first beam, -1 e to the 6 over 12, and the third term same as the first term, and fourth term same as second term but different sign. Okay, that's the first contribution of our astro. And then the second contribution is what? It's the smaller beam. Negative, what is it? 25 e to the 4 divided by 12. Sorry guys, you should see better now. And then third term same as the first term, third term same as the first term, and the fourth term same as the second term, different sign, 25 e to the 4 divided by 12. Okay, and then we add the boundary conditions. Okay, I know the beam is attached to the wall, to the cliff or whatever, and it's nicely attached, and the moment is restrained by it. So there's a hidden force and moments. Hidden force and moments along the side. I don't know it's a negative sign or positive sign. I do not know. I just know there's a force, so I just put it right there. Okay, and then I understand from right here there must be a force holding the center column, right? preventing the whole thing from falling apart. So there must be a force in the F4 node in the, guess what, in the Y directions to hold everything in place. Okay, what is it? I don't know. What sign is it? I don't know. We will let the equations look after for me. And then what else do we have? Let's do the global vector, the global force vector boundary condition. We have a lamppost acting on which node? It's node 2 in the vertical directions. Okay, remember the node V2. Okay, so will be the lamppost will be negative 2,000 pounds. Oh, I missed everything. Okay, you know what? Let's write it one more. Okay, this is not a displacement vector. Eh? I just indicate what they are. Little notes for me to remember.
And if we do something like this on the midterm, that will be fine, right?
Well, you know what? I do this because I cannot. If I zoom in, I lost my displacement vector on the side. Okay. Technically, you shouldn't. It's confusing. You know what? It's a bad example. Don't. It just confuse you. Okay. I'll zoom out a bit. Okay. Now let's put this aside. Oh. Okay. Do not do that. Okay. Bad example. What else did I miss? The half the truck. The half of the truck is what? The whole truck is 10,000 pounds. The half of it is a negative 5,000. Where do I add it? It is on
V3, row
note,
5.
yeah, that's right. Note 3 going downwards. So it will be negative 5,000. Okay, always check.
Maybe one down. I think you're writing at 5 too. Will be one down at V3.
Can be, you know, this is V1. This is a 5.1, V2, 5.2. This is V3. Negative 5,000. And this is the angle.
Yeah, that's my bad. Yes.
That's angle. Okay. And finally, we have V4Y. Okay. So let's look after the right side. The note 1 is totally locked together. So this is 0, 0. I love it. Okay. V2, side 2. No, we cannot set anything to. There's no constraint on it. No, we leave it like that. Okay. V3, oh, there's a truck coming along. There's a truck riding on it, right? So V3 will not be 0. It will be going down. However, what about the phi 3? The
It's
angle
not-
of, okay, it's going to
It's
be
not
what?
0. It's
Okay,
not 0
very good. Why is it 0 though?
because it's not attached to something, right?
No, that's not
Because
the right answer.
it's supported by that bottom beam, so it can't twist.
No, it's not the right answer. Why is the angle 3 is not, why is angle 3 0? Because everything is symmetric.
Oh, like are
When-
we assuming
when-
there is a wall attached to
When everything is
three?
symmetric, okay. What is the angle right on a symmetric point? The angle right at the symmetric point will be 0 angle. So that's why phi 3 is 0 because of the symmetry. Do you picture that? You know, when you divide something symmetrically, the angle in between them will be 0. Does it bug you? Does it like questions? No, I need some feedback, man. Okay, I see the symmetry. Okay, someone got it. Yeah, it's symmetry. When it's symmetric, angle is 0. but not displacement, eh? So node 3, V3 has something, okay? But psi 3 is 0. Okay, finally, V4, what about it? It's of course it's 0. Okay, and that's one final check, okay? If I have an unknown on the left side, I have something on the, some numbers on the right. When I have some unknown on the right side, I have a defined value on the left side. However, look at row 6. I have a value here, and I also have a value here. Okay, leave it. You know, it's fine. Okay, because if I leave it as an unknown, okay, multiply that and solve it, you will get 0. Trust me, you will get 0. But right here, I just knew it beforehand. It's symmetric, so I just apply to 0. Okay, so the next step, well, if you have this, if you show me this steps, you know, you have the global matrix, you have the global 7x7 matrix, and you have all the boundary conditions set up nicely like this. If you show me this in your exam, of course, you don't write like 7x7, eh? You have to show me some numbers. You will get 80% for sure, okay? The rest of it is just solving the equations.
So you're missing the K again.
In
On the
this
global-
case,
on the
well,
global matrix.
in this case, I don't have a common K,
Okay.
right? I have 3 different Ks from 3 different cases. I have a K from beam 1. What a mess. Well, I have a K for beam 1. I have a K for beam 2. And I have a K for the little guy as well. Okay, so I do not have a no common K. I don't have no common K, so I cannot do that anymore.
Chris, how do you get 24 on the global matrix? I thought it was 12.
This is wrong. This is wrong. It's not 24. The first term is this number times 12 plus. Oh no, hold on. Yes, that's right. It's not 24. No way. No way. Good point. No, it is 12 times K for the beam 1. Okay, we only add where's 12? Will be, look at that right here. 12 times K beam 1 plus 12 times K beam 2. Yeah, that's right, right here. The V2 row and V2 columns and V2 row. Okay. Thank you. Yeah, it's not 24. No way. 24 is not right here. It is right here. But again, it's not really 24. It's 12 times. Oh, is it 12 right here? What is the equations? Yeah. Is it 12? I don't remember that. Anyways, look up in the formula sheet.
Yeah, it's 12. I thought we were gonna find a common K factor for all 3 if we could, and then
Also, tell me, buddy, I would I would be so happy if I have a common K. In this case,
right.
no
Yeah, I don't
way.
think so. Yeah.
No, I don't think so. Yeah.
So you just multiply each matrix by their scale factor, right?
Multiply it. Okay. When you're doing locally, I don't mind you don't multiply them together. You just leave when you do a local matrix, you just leave the outside. But when you put it together, you multiply it and then you add it together.
So I did it. You can actually boil it down to 30. You can get a common of 30.
It's up to you. As long as I understand it, I know your approach in the midterm, I'll give you some grade. Okay. But even though you have a common 30, I don't think you have a common one for the little guy. For that,
You get a fraction, but it's an easy fraction. Even if you have the 30 in there.
buddy, it's your choice. Up to you. As long as I understand your approach, I will give you some credit. Okay. So you will have you're dealing with a 7x7 matrix. Okay. And I think that's a lot for you to do, but I try to be nice. When I was in school, one of the questions that I had in the final exam, I was dealing with a 12x12 matrix. That took me like 1.5 hours to finish that. No, that's why we have answers. We're dealing with a 5,000, 5 million by 5 million, but we are human beings. I promise you, the maximum matrix I will give you in a midterm exam, final, probably 8x8, 9x9. But after the boundary conditions, everything just reduce. So that's all I want to show you for today. Any more questions on midterm?
Chris, in this
Theory part, yeah. What is it?
question, did we say F1 and M1 were the reactions?
Reactions, yes.
Okay.
Maybe I should label that reaction F1 and M1 reactions.
If you get the chance, can you just post the like the final answer for that question?
This question.
Yeah.
Why do
like
you
not
care?
not the whole process? Well, because I don't know. I feel like I struggle with doing the system of linear equations to solve for the.
You know what? I might forget about it, so I'll just look it up. I did that long time ago. Yeah. Okay. V3 is -716 inch. Okay. So the truck sinks. Okay, always remember when I see the answer, I expect units. Because if you just give me like a V3.716, it doesn't make any sense to me. Is it meters, feet? No, you have to give me inches. And number two is I pay attention to the sign as well. If you say V3 is -0.716, and then you in your final statement you say the truck sinks, okay, 0.716. Don't say the truck sinks negative. You have double negative, it doesn't make sense as well. So okay,
thank you.
You're welcome. Okay, any more questions on theory, midterm exams? There will be 4 questions, okay? And don't worry, I will give you enough time to download the problem set. I mean the midterm exam, and then I will give you enough time to upload it, okay? And I'm still fine-tune it a bit. I designed the midterm exams just last night. I'm gonna work through it one more time, probably a few more times to make sure there's no error, and then I will issue that and for you to work on.
Sir?
Yep.
How many questions in the midterm?
4 questions.
4 questions.
4 questions. You will have enough time to do so, okay?
So
and
have the different element, right?
Spring element, truss elements, beam elements, and also you must understand the special load by the minimum potential energy. Okay. Anyways, the formula sheet I gave you this morning is a perfect study guide. Okay. Make sure you feel comfortable how to use the equations in the formula sheet.
One final question.
Yep.
So what will be the form of the midterm? Will it be like a quiz on an avenue or an assignment, a Dropbox for the assignment where we just
It's
submit
Yeah, that's right. It's no different from an assignment. Okay, it is same as the assignment, but you must work on that specific time slot next week from 9 to noon. And again, if you're late, there will be penalties. You know, I might close the inbox. You cannot submit that anymore. And one thing though, I really prefer you to put it in the PDF format. Okay, that's my favorite. You know, that's easy for me to evaluate. And also, I've seen that before. You know, people take like high definition pictures and then submit that into a Word format and then print that in PDF. And the document is like 25 megabytes. It took me like 10 minutes to download and see your work. Please don't do that to me, you know. Try to restrain that under 10 megabytes, you know. I will give you more details. I'll send you an email to specify that when I or put it in the instruction, okay? And the best way to prepare that, you know, to work through all the examples I provide in the class, review your quizzes, and don't panic. You know, FEA takes a lot of patience and also attention to details. If you mess up one box, you know, one entry in a 7x7, you get a wrong answer. Okay.
Are we gonna have a Zoom meeting next week, or if we have questions, are we just gonna email you?
Again, I will specify the instructions. I specify that in the instruction, you know, midterm send. I will have a question period in between, and then I will leave the meeting on, but I will not be standby all the time. I will come and check your chat every like 10, 15 minutes, you know, and make sure you're all right. But I have a question period, you know, in the beginning. I let you go over all questions, make sure you're all right. Then I'll go do something else. I'll mark your quiz, mark your answers report just in case, you know.
So where
Okay.
did you post the formula sheet? I don't see it on Avenue. Is it under a specific?
No, I sent it through email. Did you get it? Did you check your email?
I saw I have a little gift for you, but it's nothing attached. Oh, hold on a sec, maybe. Okay, I missed it. It's on the bottom. Yeah. Okay.
Merry
Thank you.
Christmas. Okay.
Thank
You
you.
happy? Hey. Okay. Any more
By the way-
questions on midterm theory? Okay, no, 2D elements will not be on it next week. Okay.
Yeah, Chris, since you said about the ANSYS in the lab, I didn't see anything. Well, this is not a part of the midterm, I know, but we haven't received a lab, or well, I haven't received any lab or anything regarding ANSYS. Am I right? Yet?
Well, it's in your assignment box, right? I believe lab 1 and lab 2 is already posted. Okay. Anyways, if you haven't started any lab 1 and lab 2, it's a bit late, but not enough to panic. But after midterm, I really want you guys to catch up. Okay. It's under the assignment, assessment under assignment. That's right. You have so far I have a quiz 1, 2, 3, 4, and then I have post lab 1 as well. And lab 2, 3, 4, 5, I have posted but not visible yet. Okay. And you will see something next week for a midterm assignment. Okay. There's a link to it. But again, I will provide all the instruction beforehand. Okay. Okay, that's it for today. You know, any more questions, you can send me an email and I'll reply you soonest. Okay. So remember, have enough rest before your midterm exam. Get a quiet place and have some blank paper ready, you know, because you'll be a lot of writings. And try to make it tidy, you know, easy for you to debug, easy for me to evaluate as well. And that's about it. That's all I want to say. And thank you once again for attending my class. If you have any more questions, feel free to email me. Okay. And good luck to you and see you next week.
Thanks, sir.